Okay, hi everybody. Hope you're all doing well. This is the first lesson for probability distributions. Our unit number 4 now. Nope, not 4, sorry. How many units have we done now? 3. So this is, no, it is unit 4. So today we're going to talk about probability models and what a distribution is. So a distribution, when I'm asking about a distribution, it's really just a chart, a table, or a graph that describe the probabilities of every outcome for a specific event. And I'm going to underline the word every outcome because it really does encompass every single outcome. So last unit in probability, if you remember, we talked a lot about single probabilities or a specific probability. Now we're talking about many probabilities that make up an event. A random variable is a numerical value, numerical is important, assigned to each outcome in a probability distribution. It can be discrete or it can be continuous. If you remember, a discrete variable are values that are whole numbers. They're separate from each other. An example of a discrete random variable is the number rolled with a die. When you roll a die, you can get a 1, 2, 3, 4, 5, or 6. That's it. Those are discrete numbers. No decimals allowed. Continuous variables have an infinite number of values in a continuous interval. So the height of students, weights, time it takes to finish homework, all of those can be measured to a decimal. That's what makes them continuous. And finally, a uniform probability distribution. Each outcome has the same chance of happening. So I'm sure you can think off the top of your heads right now what a uniform distribution might look like. And here's a good example of that. Example 1. What's the distribution for the roll of a single die? So if we're looking at a distribution, usually what we start with is a chart. And this chart is a distribution chart where X represents what we're measuring. In this case, we're measuring the roll on a single die. That is our numerical random variable. And our random variable here, what is possible as a roll? Well, we could get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. Those are the possible rolls. The probability of each one, we all know, is the exact same. It's 1 in 6, all the way down. 1 in 6, 1 in 6. All of these have the exact same probabilities, which makes them a uniform distribution. That's a uniform distribution. And so if we were to graph this now, a different way of representing this distribution is to graph it. Here's the probability. Here is the roll. And I'm going to do this very quickly. I don't have a ruler handy, unfortunately, but if I did, I'd make this a lot better. So a 1 in 6 distribution means that everything has the same probability of happening, and so we end up with something that looks like that, where every single bar in this distribution, and it has to be a bar graph. Why would you think it has to be a bar graph and not a histogram? A bar graph has spaces in between the numbers because each one is individual. You can't have 1.5 as a roll, for example. But you can have 1, you can have 2. That's a discrete variable. Okay, let's move on to B. Determine the probability distribution for the number of heads. Okay, there's my random variable. I'm looking for a head if a coin is tossed once. Well, let's set this up. Here is my distribution chart, and according to this, X, my random variable, represents the number of heads I could get if I toss a coin once. Well, if I toss the coin once, I could get 0 heads. Remember, this is a numerical value, 0 of those things, or I could get 1 head. What's the probability of getting 0 heads? Well, the probability of that, px, is 1 in 2. That means I must have flipped a tail. What's the probability of flipping 1 head? That's 1 in 2 as well. So there's our distribution for the number of heads if a coin is tossed once. This is another example of a uniform distribution because the probabilities are equal. They're the same. And then we look at C. Here it says, what's the distribution for the number of heads again if the same coin is tossed twice? So now we have 2 tosses of a coin. And let's think about this. If we toss the coin twice, we could get a total of 0 heads in 2 flips. That means we flip tails twice. Or we could get 1 head in 2 flips. Or we could get 2 heads in 2 flips. Now let's think about that. The probability of 0 heads means we've got a tail, then a tail. And that, out of 4 possible outcomes, is a 1 in 4 chance. There's a 1 in 4 chance I got a tail, then a tail. Let me explain a little bit further. Head, tail, head, tail, head, tail. Here's my tree diagram to represent this situation. Head, 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 tail, tail, head, tail, tail. That's just one of the outcomes, tail, tail, out of 4 possible outcomes. When x is 1, that means I must have flipped 1 head in 2 flips. Well, 1 head, either I do it this way, head, tail, or I do it that way, tail, head. So there's a 2 in 4 chance of that happening. And what about 2 heads? Well, that's this outcome, head, head, a 1 in 4 chance of that. Now, it's interesting to note that for both of these examples, when we add up the probabilities, the sum is equal to 1 for both. And why is the sum equal to 1? Because this is every single possible probability. This is every event that could happen for this number of heads when you flip a coin twice. That's what a distribution is all about.